So now let's look at a few more of the common Taylor series functions. So some of these I'll just write down rather than going through all the derivatives and looking for the pattern. But as always, it's a good thing to practice on your own. The natural log, for example, oftentimes the natural log is reported as 1 plus x. This is because if we do the natural log of x and we center it at 0, that doesn't really make any sense, right? Because the natural log is not even defined at 0. So often we look at 1 plus x instead, but the 1 is kind of arbitrary. You could do it anywhere away from just x. So this one's from n equals 1. So note the difference in the index here. N equals 1 to infinity of negative 1 to the n times, or n plus 1 rather, times x to the n over n. Okay, so no factorial in the bottom, just regular old n. So every other term is going to be negative here. Its interval of convergence is from negative 1 to 1, including 1, not including negative 1. Again, because natural log isn't even defined at 0. So that wouldn't really make any sense. Okay, so but a very limited interval of convergence for this one. Okay, one that's really important would be 1 plus x to the r, where r is any positive power, right? So this opens up the door to a lot of different types of functions here, right? Now this itself is a polynomial, so you know, in general, the Taylor series of a polynomial is the polynomial itself. But it can get pretty lengthy, so instead we use this general form here of r choose n times x to the n. If you're not familiar with this choose function, I think it's popped up once before on a homework assignment, but this is equal to r factorial over r minus n factorial times n factorial. Okay. And this is going to be also converging from negative 1 to 1. Okay. Cosine, another helpful one to know here. Okay, this is equal to n equals 0 to infinity of negative 1 to n x to the 2n over 2n factorial. And this is actually from negative infinity to infinity. It'll converge. And then sine is pretty similar. It's just basically moved over a bit, which shouldn't be too surprising since that's how sine and cosine are in general. They're the same function, just moved over a little bit in terms of the graph. So this is x to the 2n plus 1 over 2n plus 1 factorial. Okay, and it has the same interval of convergence. Okay. And then we already saw the geometric series. I guess I can write it down again, just so we have a convenient list here of 1 over 1 minus x. Right, this is equal to n equals 0 to infinity of x to the n. And we saw just how many different ways we can manipulate that. So with all these functions, we can manipulate them a lot to get these, get different functions out of just this simple list of them.